All right, let's look at section 8.3, in which we solve inequalities. Number one gives us the same piece on the left side, y plus 4 over y minus 5. And then the four different kinds of symbols that we might encounter. So this is a good problem to think about. For the rational inequalities, we set both the numerator equal to 0, which will give us y equals -4. And we will set the denominator equal to 0. So these are what we call turning points. They're the important values here. -4 is a solution. Y equals 5 is the asymptote. But we set the numerator and denominator equal to 0, and this gives us our key points, or the turning points. I've seen it called different things, but we really just need to do this once, where we do a test. Here on A, the symbol is less than or equal to 0. So we're really asking, where is the rational function here? Negative. An important note is that we will always use parentheses in the denominator, because we can never be equal to +5. Even though there's a line underneath the symbol, we cannot be equal to +5. Of course, Alex will mark this entirely wrong if we do. It's not a huge deal for me as I'm grading the test, but that we should never use a bracket around the denominator, around the asymptote value. We can use a bracket around -4, because there's a line under the symbol. And again, if it helps you think about it, this is a solution. Setting the numerator equal to 0 will yield a solution, but this is our asymptote. Setting the denominator equal to 0 is an asymptote. So again, we can use brackets for a solution, but we must use parentheses for the asymptote value. So let's test anything to the left of -4, like -10. We can test 0, because that's between -4 and 5. Always use 0 if you can. And something to the right of 5, like +10. We can plug these in, and I guess I'll do that up here. Let's test -10, meaning we plug it into the rational function here. -10 plus 4 over -10 minus 5 gives us -6 over -15. But all we care about is, do we get a positive or negative value? A negative divided by a negative is positive. So, however you write it down, on the number line here, we are positive in that region. If we test 0, if I zero out the y's, then we're just left with +4 over -5, which is a negative value. Again, we only care, are we above or below the x-axis? Or do we have a positive or negative value? Of course, we can check this in the calculator as well. So let's do, I already have it in there. We use x, of course. So x plus 4 divided by x minus 5. This is what the graph looks like. We have at negative 4 our 0. It tells us that. Let me move this around. At negative 4, we have a 0. If I trace at positive 5, the other turning point, we can see that that is not an included solution or an included point. But once you know the turning points, you can just go to the table. Anything to the left of negative 4 is positive. We see these positive y values to the left of negative 4. If we test at 0, we see that now we have a negative value. And so everything from negative 4 to 5, any of these points after negative 4 are negative. So that region is negative. And then after positive 5, so there's the error, meaning it's not an included point. After positive 5, anything after that, we see that the values are positive. So you can plug them in and determine if it's positive or negative. But we can also, once we know what the turning points are, just go to the table and see if it's positive or negative. So we'll put the answers in purple here. Part A, we are less than or equal to 0. We only need to do this once, and then this will apply to all of the problems. So where is the graph negative? With a line under the symbol, meaning we can use a bracket around the negative 4 here. So where is the graph negative? From negative 4 to positive 5 with a parenthesis. So for part A, it is negative 4 with a bracket to 5 with a parenthesis. And once again, that's because we cannot be equal to positive 5, because that would put 0 in the denominator. So what's the difference between part A and part B? The only difference is there's no line under this symbol, so we will not use a bracket. Where is this function less than but not equal to 0? The answer is parentheses negative 4 to 5 with parentheses. And then we are asked, where is the graph greater than or equal to 0? And then just greater than 0, which again, this means that we're asked, where is the function positive? And we can see from the table, or we can see from the graph, these are very slight positive values. But if I trace at like negative 8 and hit enter, it is a very small number, but it is positive. So we're positive in our first region, and then of course we're positive after the asymptote. So a line under the symbol means we can use a bracket for the solution. So we have these two regions. We go from negative infinity to -4 with a bracket, because that's included, unioned with parentheses 5 to infinity. Because, of course, the number line goes from -infinity to +infinity. We found a solution and an asymptote, so we have 2 turning points, which means we have 3 regions to evaluate. And then, of course, the only difference from D and C is there's no line under the symbol, so it's parentheses all the way through. And there's number 1. For number 2, again, we find our turning points by setting the numerator and denominator equal to 0. A lot of students subtract 2 and then divide the -1. You can just add x. So there's a solution, x equals 2. And then x plus 9 equals 0 gives us our asymptote. So these are the regions that we consider. We go from -infinity to -9. There's a region between the solution and the asymptote, -9 and 2. And then we go from 2 to infinity. And again, we can test these, or, to save time, we can just go to the table. I like to use -10. Anything to the left of -9 would work. Anything between -9 and 2, like 0. And then we could test something greater than 2, like 5. And again, we only care, are we positive or negative? As I put these in the calculator, I like to put parentheses around my polynomials. So parentheses 2 minus x, close parentheses, divided by x plus 9 in parentheses. We can look at the graph. There's the asymptote at -9. We have a solution at 2. I can trace, hit 2, hit enter. And that verified that that's a solution. So let's go to the table. And let's test these values. When we are to the left of -9, like -10, go all the way up. Again, there's the error for the asymptote. But after -9, to the left of -9, all of these values will be negative. So we're negative right here. Between -9 and 2, these values are positive. So there's the test value at 0. We can see that it is positive. So we're positive right here. And then to the right of 2, something like 3. So I keep moving down my x column. And everything to the right here is negative. We see the negative sign. Of course, you could take the time to test these points. All we really care about is it positive or negative. We could not use brackets around the -9, but we could use brackets at 2. So this is asking where the function is positive, where it is greater than or equal to 0. And it's in this region right here from -9 to 2. But to get this correct in ALEKS, you have to use the right parentheses and brackets. It's not left to right, it's which one is the solution, gets the bracket, which one is the asymptote, gets a parenthesis. So, -9 with a parenthesis to 2 with a bracket. And again, I feel like some students will think it maybe goes left to right, but -9 there gets the parenthesis because it's in the denominator. Finally, number 3. Solve 6 minus 2x over x squared is less than or equal to 0. So we are asking where is the function negative or equal to 0. We can set the numerator equal to 0. I would add the 2x and divide the 2. So we get x equals 3. We can use brackets around that because it's in the numerator. And then if I said x squared equals 0, you could take the square root, but it's just 0. So only 2 turning points, meaning 3 regions to consider. Move this down. So you can test the regions on paper. We could also put this in the calculator. Do 6 minus 2x in parentheses divided by x squared. So 0 was in the, when we said x squared equals 0, we get an asymptote at 0 here. So the graph repels away basically from the y-axis. So on the number line here, from negative infinity to 0, we have 0 to 3 and 3 to infinity. Where is the graph negative? So we can test something to the left of 0. We can go right to the left of 0, like -1. Second table, or second graph to pull up the table. There's the error at 0. That's our asymptote. We can see that we get a positive value to the left of 0. All of these values are positive. They get increasingly smaller, but they're still positive. They never become negative. They just get kind of infinitely closer to 0. So they're positive to the left of 0. So right here we were positive. We're asked where is the function negative. From 0 to 3, we're still positive. We're positive at x equals 1 and x equals 2. So we are still positive in this region. But after 3, we finally start to get negative. Very small negative values, but infinitely negative. So number 3 is asking where is the function negative? And the answer is from 3 to infinity. 3 was a solution, not an asymptote. So we can do bracket 3 to infinity. And there's 8.3. So let me know if you have any questions.